Welcome. In this particular video, we'll be solving trigonometric equations involving sine part 4. Let's take a look at our example. Example 1. Solve the equation given below for theta greater than or equal to 0 but less than 2 pi. Here, our equation is the opposite of square root of 3 over 2 is equal to sine of negative 3 theta plus 3 pi over 4. So, in order for us to solve this, let's go ahead and introduce a new variable called alpha, where alpha is just this input here. So we can say let alpha be equal to negative 3 theta plus 3 pi over 4. Now, with that substitution, we can get the following equivalent equation. So we have negative square root of 3 over 2 is equal to sine of alpha. Now, using the fact that y is equal to r sine of theta, and that we're dealing with the unit circle, so the radius is equal to 1, so we can substitute in that for r, we get that y is equal to sine of theta. So we're looking for any angles whose y coordinate happens to be negative root 3 over 2. Now, looking at the unit circle, we look for those points with such coordinates. And here's one of those points. And we can also get the reflection across the y-axis, and that should work. So those angles alpha happen to be 4 pi over 3 and or 5 pi over 3. Now, we're going to use that along with the previous substitution to solve for theta. So for alpha equals 4 pi over 3, let's solve for theta. So we get that negative 3 theta plus 3 pi over 4 is equal to 4 pi over 3, which is the right hand side over here. Now, solving for theta requires us to subtract the 3 pi over 4 from both sides. So we get that negative 3 theta is equal to 4 pi over 3 minus the 3 pi over 4. Now, looking for the same denominator, we can say that the common denominator is 12, so we get that this is going to be rewritten as 4 pi times 4 divided by 3 times 4 minus 3 pi times 3 divided by 4 times 3. Now that gives us the following equation. Negative 3 theta is equal to 4 times pi times 4 is 16 pi over 12, because 3 times 4 is 12, minus 3 times pi times 3, which is 9 pi over 12, because 4 times 3 is 12. So this gives you 16 pi minus 9 pi, which happens to be 7 pi all over 12. So we have the equation negative 3 theta is equal to 7 pi over 12. Now, solving for theta requires us to divide by negative 3 on both sides of the equation. Hence, you get that theta is equal to 7 pi over negative 36. However, this doesn't satisfy our given constraints, since theta is to be between 0 and 2 pi. So what we need to do is to look at the period of our function. The period of this given function is equal to 2 pi, the original period for sine, divided by the absolute value of the coefficient of theta. Well, the coefficient of theta happens to be negative 3. So your period here is simply 2 pi divided by the absolute value of negative 3. In other words, this is just 2 pi over 3. So what we're going to do to get our angles is as follows. We're going to take theta to be 7 pi over negative 36. Now, since we're dealing with 36, we're going to change the period involving 36's. So this is going to be 2 pi over 3 times 12 over 12, which will give you 24 pi over 36. This is a period, so we're going to add that to it. So we take the 7 pi over negative 36 plus the 24 pi over 36. Now, doing the basic math here, we have 24 minus 7 gives you 17. So this is just 17 pi over 36. So this is our first angle, so 17 pi over 36. Now, to get the next angles, we're going to keep adding the period. So we take this previous angle, so we say, okay, theta could also be 17 pi over 36 plus the period of 2 pi over 3, which is equivalent to 24 pi over 36. Now, 17 plus 24 gives you 41, and this is pi over 36. Now, this angle is still between 0 and 2 pi. Now, to double check, we need to make sure that we are always less than 2 pi, which in terms of 36s is 2 pi times 36 over 36, which is equal to 72 pi over 36. So we're fine still. So for the other angle theta, what we're going to do is to take the 41 pi over 36, and we're going to add the period of 2 pi over 3, which is the same as 24 pi over 36. Now notice that this will give you 41 plus 24 gives you the 65 pi over 36. So that's another angle here. Now if we were to add another period of 2 pi over 3, which is equivalent to 24 pi over 36, this is going to take you to 89 pi over 36, which is already past the 72 pi over 36 corresponding to the 2 pi. So we're going to stop there for this particular angle's theta for the given alpha. However, we now can use the other value for alpha, since these theta values were actually given for the first value of alpha of 4 pi over 3. So going back to the other value for alpha, we get 5 pi over 3. Hence, we can say 4 alpha equals 5 pi over 3. Let's solve for theta. Okay, but in this case, alpha was equal to negative 3 theta plus 3 pi over 4. And that's your left-hand side, but your right-hand side is equal to 5 pi over 3. Now, we need to solve for theta. To do so, let's subtract the 3 pi over 4 from both sides. So this leads you to have negative 3 theta is equal to 5 pi over 3 minus 3 pi over 4. Now looking for the common denominator, we notice that it has to be 12, so we can multiply the 5 pi over 3 by 4 over 4. And then we can multiply the 3 pi over 4 by the 3 over 3. So we get that negative 3 theta is equal to 5 times 4 becomes 20. You still have the pi in there, over 12, minus 3 times 3 is 9. You still have the pi in there, over 12. So this is equal to 11 pi over 36, or over 12, I'm sorry. Now with that in mind, we have that negative 3 theta is equal to 11 pi over 12. Now let's divide by negative 3 on both sides. So that leads you to have theta is equal to 11 pi over negative 36. Once again, this is an angle that it's not inside our constraints for this problem, because we need theta to be between 0 and 2 pi. So what we're going to do is to take this angle of 11 pi over negative 36, and we're going to add the period of 2 pi over 3. Now again, we're going to multiply this one by 12 over 12 to get the same denominator. So we have 11 pi over negative 36 plus the 24 pi over 36. Now subtracting this or combining like terms, this now becomes 13 pi over 36. And this is an angle that works perfectly fine because it's between 0 and 2 pi. Now, for the next theta, we're going to take this particular value. So we have 13 pi over 36, and we're going to add the period. Now, the period is 2 pi over 3, which corresponds to 24 pi over 36. So let's add the 24 pi over 36, and we get, okay, 13 pi plus 24 pi becomes 37 pi all over 36. This is still fine because it's less than the 2 pi, or 72 pi over 36. So we take, once again, this angle here, and we're going to add another period. So we have theta is equal to 37 pi over 36. And let's actually add the period of 2 pi over 3, which corresponds to 24 pi over 36. And we get that this happens to be 61 pi over 36. Now, if we were to add another period, you notice that 61 plus 24 will give you the 85, which is far beyond the 72 pi over 86 that we want. So one can conclude, therefore, that the solutions for this particular problem are as follows. We had 13 pi over 36. We also had 17 pi over 36. We had 37 pi over 36. We also had 41 pi over 36. We had 61 pi over 36. And lastly, but not least, we had 65 pi over 36. So this particular equation had a total of 6 different solutions. And that concludes this particular video. So thank you for watching and have a wonderful day.